Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 1 from the January 2018 International A-Level Statistics S1 paper. Now, this question has been requested by one of the viewers on the channel, actually, for me to answer. And so I'm going to go through this. I think they're more interested in the last parts of the question, but I will answer the whole question so that it's complete. So there's two classes of students, Class A and Class B. They sat a test. Class A has 10 students and Class B has 15 students. Each student achieved a score X on the test and their scores are summarized in the table below. So Class A, you have 10 students. This means the sum of their scores was 770 and the sum of the squares of their scores was 59,610. Class B, there were 15 students who sat the test. The sum of their scores is unknown T. And the sum of the squares of their scores is given as 58,035. The mean score for Class A is 77. Okay, so I'll add a new column here. So the mean score for Class A is 77, and the mean score for Class B is 61. I'll just put the mean there. It says find the value of T. Find the value of T, which is the sum of the scores of Class B. Okay, so T is the sum of the scores of Class B. I'll write that as that. Okay, so what we know is we know the number of students and we know the mean of the scores. So we know that to find the mean score, we take the sum of the scores, okay, which is what we have to find, and divide it by the number of students in that class. So if we just apply that, we know the mean is for Class B is 61. And we know the sum of the scores is T, which we're trying to find. And we know the number of the students is 15. So from this, we can say that T is equal to 15 multiplied by 61. So we get 15 multiplied by 61. 15 multiplied by 61, which gives us 915. 915. Okay, that's the value of T. Okay, it's the sum divided by the mean, by the number of entries gives you the mean. Okay, so we can make a little test. 915 divided by 15 gives you 61. Okay, so we know we found the value of T, and that is 915. So 915. I'll write it like that now in case we need to use it again. All right, now it says calculate the variance of the test scores for each class. Now the variance is given by the equation. The variance is basically the mean of the squares minus the square of the mean. So in this case, it's going to be the sum of the squares, so sigma x squared, the sum of the squares divided by 2, that's the mean of the squares, minus the square of the mean. So we find the sum of the squares divided by the number of entries and then square it. So we need to do that for each class. So for A, we can say the variance of A is going to be the sum of the squares of A. So here we have the variance of A. Now the variance is the mean of the squares minus the square of the mean, as we just mentioned. So we need to have the sum of the squares for A, which is given as 59,610. So we have 59,610 divided by the number of entries for A. Class A has 10 entries, so that's divided by 10, minus the square of the mean. So we're going to have the square of the mean. Now the mean, as we're told, is for Class A is 77. Exactly 77. That's not a rounded value, so I can just write 77 squared. If it was a rounded value, I would use the exact fraction used to calculate it. But in this case, whoops, we don't need to do that. So I can just put here 77 squared minus 77 squared. And that will give us our answer for the variance of A. If they said standard deviation, we would find the square root of that, but they didn't. They said variance. So we got, this is going to be basically 5,961. 5,961, because you're dividing by 10, minus 77 squared. Okay, that gives you 32. So the variance of A is 32. And for B, we can say the variance of B is going to be given by the mean of the squares. For B, it's going to be 58,035 divided by 15. So 58,035 divided by 15 minus 61 squared. 61 was the mean of B, which they told us about. So we're going to take this as well. So we have 58,035 divided by 15. And that, we've got to take away from that 61 squared. Okay, that gives us 148. Okay, so the variance of A and variance of B, done. It says the highest test was 95 and the lowest score was 45. These were each scored by the students from the same class. So the highest score out of all the students and the lowest score out of all the students was from the same class. State with the reason which class you believe they were from. Okay, so if that was the highest score in both classes and that was the lowest score in both classes, then that means the spread of scores in that particular class must be, higher than the spread of the scores in the other class. The one which has a bigger, range. Okay, the range of scores is bigger in the class which had this as the highest and that as the lowest. So, of course, the one that has a bigger variance is the one that's going to have the scores that are more spread out. So we can say that, we can say that class B has the larger variance, so will likely have the greater range of scores. Okay, so we say therefore class B. Okay, so that's enough for you to get the marks for that. And that's the answer to part C. Part D on the next page. Now for part D of the question, says the two classes are combined into one group of 25 students. Find the mean test score for all 25 students. Find the variance of the test scores for all 25 students. So for part one, I've got all this summary kind of information from the last part, from the last page. So we have everything at hand here. So the mean for all 25 students. So that means, as we know, that the mean is the sum of all the scores of every student divided by the number of students. So here we have the sum of the scores of the students in class A, and here the sum of the students in class B. So we have to add them together. So we have 770 plus 915, and we divide it by the total number of students, which is now 10 plus 15, which is 25, and that should give us our answer. So we have to divide 770 plus 915 by 10 plus 15, which is 25, which gives us 67.4 exactly, 67.4. That's an exact value, it's not rounded. Okay, that's the new mean. Okay, that's the mean for all combined. That's like the combined mean, you can say, combining the two classes together. And for the variance, we know that the variance is the mean of the squares minus the square of the mean. So we got to add together the sum of all the squares of all the entries, which is these two added together. So it's 59,610 plus 58,035 divided by the total number of students, which is now 25, minus the square of the mean. Well, we know this is the mean, so we can just square this. It's the exact value, so we don't have to worry about using the fraction that we had before because it was the exact value, so it's going to give you the same answer, so it's fine. So now we're going to have a fraction. We have 59,610 plus 58,035 divided by 25 minus 67.4, and that has to be squared. And that gives you 163.04. I'll leave it like this as an exact value. And there we have the mean and the standard, the variance of the new or the combined scores for both classes. Okay, so that answers question D, part 1 and 2. Now for part E, the question states that the teacher of class A later realizes that he added up the test scores for his class incorrectly. Each student's test scores in Class A should be increased by 3. Without further calculations, so this is very important, no calculations, without further calculations, state with a reason the effect that this will have on these 3 things. So firstly, the variance of the test scores for Class A. So the Class A marks are what are going to change by being increased by 3. Now, the variance of a set of data is a measure of how spread out that data is. And increasing the marks or adding or subtracting by a certain amount does not change the range of the data. It doesn't change the spread of the data. Okay, so if we are talking about the variance of the test scores just for Class A, and it was Class A whose marks were increased by 3, the variance would be unchanged. So as an example, this is not, to show a calculation, but just an example. If I was to take this set of data and increase them all by 3, so this would become 4, this would become 5, this would become 6, 7, and 8. Right? So I've increased each of these entries by 3. Now we can see that the variance, or the range of the data, is 4, and the range of the data here is still 4. It hasn't changed. Adding and subtracting does not change the range of the data. It does not change just how spread out the data is. Okay, so adding or subtracting something to all of the marks in Class A, so adding 3 to each mark in Class A will have no effect on the variance. Okay, so the variance will be unchanged. So I'm going to say variance is unchanged. Why? Because every mark increases by the same amount. Okay, amount. Let me spell it properly. Excuse my bad writing. Okay, every mark increases by the same amount. Okay, so the spread of the data is unchanged, and variance is a measure of spread of data, is unchanged. Okay, so that's about the variance. So the variance will still be the same for Class A. If you added 3 to each of the values, you'll still have the same spread, okay, of data. All right, now number 2, the mean test scores for all 25 students. Now remember, the mean is the sum of all the entries of all the 2 classes, okay, the mean for all 25 students divided by 25, right? So if you increase the test scores of the boys in Class A, then this is going to increase. The sum of X will be higher for A. Okay, the sum of X for B will be the same, but the total sum of Class A plus Class B will be increased, yet the number of students will still be the same. So the mean is going to increase. The mean, okay, is increased. The mean is increased. Okay, so I can say the mean increases. Why does the mean increase? Because we can say the total sum of marks is higher, yet the total number of students remains the same. Okay, so of course that will cause the mean to increase. Okay, so the variance is unchanged, the mean increases. Now, part 3, this is a bit more tricky. It says here, the variance of the test scores for all 25 students. And now they're talking about the variance of all students. Okay, now what's going to happen here? You see, not every single data entry is going to change by the same amount. Some data entries will stay the same, and some data entries will increase by 3. So the spread of the data is not going to be like for A, where everything changes by the same amount. So you'll have some entries which will stay exactly the same, and some entries which will increase. So if some entries stay the same and some entries increase, that will cause the mean to increase. Okay, so the variance, okay, what we can say is if the mean increases, then what we can say is that the data entries, okay, which stayed the same, will now be further away from the mean than they were before. Okay, the change, because the mean will get bigger, and the mean you can see of the class A is higher than class B. So in general, if the mean goes higher, then you could say that more of class B have got values which are in the lower end compared to class A in general, because their mean is lower. So if the mean of the overall mean increases, the distance between the values of class B and that mean will increase. The distance between class A and that mean will basically also change, but as they will also increase, it won't make such a big difference. But for B, they remain exactly as they are. The B values stay as they are, but the overall mean of both sets of data will increase, okay? Which means that the variance is going to increase because the distance between the data values that were unchanged and the data values and the new mean is going to be bigger. So we can try to explain that in this way. So we can say that, okay, as the mean increases, the overall mean increases, okay, which it will do because some of the data values are higher, and so you know you're going to divide by 25, but there'll be a bigger sum. Okay, so you can say that you know the total sum is higher, the total sum is larger, while the number and the number of students is the same. Okay, that's why the mean increases. Therefore, the data entries, okay, of set B, of class B, okay, will have a greater, okay, spread from the new mean. Okay, so which means, therefore, that means the variance increases. Okay, because if the mean goes up, some data entries will remain the same, okay, and some data entries will increase as well. But especially the ones that remain the same, there will be a marked difference between how far they are away from the old mean to the new mean. So that means if you remember the variance its origin is this: x minus x bar squared over n. Okay, and that basically is the sum of how far every item is away from the mean squared divided by the number of entries. That gives you the variance. That's the original formula for the variance. We use the mean of the squares minus the square of the mean because it's easier, but that's the original form. So if you have this greater gap between some of the data entries and the mean, then the variance is going to be bigger, of course, because this will be bigger. So hopefully that is something which everyone understands and can decipher from my terrible handwriting there. But that concludes this question number 1 from the January 2018 Statistics S1 paper from International A-Level Edexcel. Other questions from this paper can be found in the playlist, which will appear somewhere in this region at the end of the video. Other questions from the topic of, this is to do with standard deviation and variance. Okay, what else was there? I guess that's what it was really about. Standard deviation, variance. Okay, so I'll find a category of playlist to put it in there. You can subscribe to my channel by clicking on this link, and you can watch this video here. which is linked over here, which shows you how to use my channel to find what you're looking for. Thank you for watching and see you soon.